In this video I will give a brief introduction into the StdpC software and its configuration. What you see here is the main StdpC window with the elements of menus up here, and we will use them in a second. You have the start and the stop button, the choose box for the data acquisition board, a message box on the left, a box for defining synapses here on the right, and below it a box for defining ionic conductances, the spike generator box, and two displays for testing and for observing the experiment online. For the basic configuration of StdpC, you need to do several things. You need to choose a data acquisition board. Here I have chosen National Instruments. Then the software automatically detects which data acquisition board is actually connected, and it gives a message that looks like this: good news, and then the name of the data acquisition board. In this case we have a PCI 6229 National Instruments board, so PCI 6229 found and opened successfully. After choosing the board, we have to configure the board, which we can do at config, duck. In this case all we need to do is put the right device name. This is the device name that National Instruments software gives to their hardware. The standard is device 1, dev 1, like it is here, which is the standard for National Instruments and the standard in StdpC. So normally you shouldn't have to change anything. You click OK. Then configure the input and output channels. To do so, you go to config, input channels, which shows you a dialog like this. It has all the available input channels. On our board we have 32 input channels, 0 to 31, and we choose which ones to use of them. Assume that we will use 2, so I mark these 2. Then we have to decide on an acquisition range. This depends on the amount of voltage that you are trying to measure. In our case we have neurons, which roughly speaking have voltages between -100 and 100 millivolts, and our amplifier amplifies 10 times. We have choices here: 0.1, 0.2, 1, 5 and 10 millivolts range. And as we have 10 times amplification of a 100 millivolt signal max, we can use -1 to 1 volt on both of the channels. Then we have to give this conversion factor that I just mentioned also directly to the software, so that it knows how to interpret the signals. And this is done as the ratio between the voltage in the world, this is the voltage at the neuron, and the voltage at the data acquisition board, which is 10 times amplified, and that gives us a factor 0.1, which is already entered here correctly. Spike detection is important for some of the plasticity functionality of StdpC and other advanced functionalities which we don't use here, so I leave these unchecked. The detection threshold is related to that and only matters for when this is checked, so I don't change these values. And then we can choose to save the channels, and I've chosen here to save these 2 channels. When you're satisfied with the configuration of all channels, you click OK, and that configures the input channels. To configure the output channels, you go to config, output channels, and you get a similar dialog. Here we have again 4, in this case, output channels, which was detected from the device, that's what it has. You can choose which ones to use. We are only going to inject in 1 neuron, so we only use 1. We have an acquisition range. In this case it's only 1 possible range, so we use that. And another conversion factor. In this case it is the voltage command at the data acquisition board generates how many nanoamperes that are injected into the cell. This depends on the amplifier that is used. Our amplifier does a 10 nanoamp injection for each volt at its input. So it's 10 nanoamps per volt, or in this writing here it's 0.1 volts per nanoampere. Additionally, we can put in a bias current to the neuron. That's important for some applications, not in this case, so I leave this at 0, and I save this channel as well. To now actually simulate an electrical component in the cell, we need to configure which components to simulate and which parameters to use. And I'll show the example here for chemical synapse. So I've already chosen here chemical synapse. And then if I hit parameters, I see a dialog like this, on which, importantly, I have to first choose the channels that are involved in this simulated component. That means I have a presynaptic channel. This is the membrane potential of the neuron that's presynaptic to the simulated synapse, and I use here channel 0. In principle, I have a choice of all the activated channels, that was 0 and 1, or the spike generator channel, which is the artificial neuron. So I stick with 0. For the postsynaptic channel, I will be using channel 1. This is the membrane potential of the postsynaptic cell. It comes in at input channel 1. And then we choose an output channel. This is where the current command is issued, and we're going to use channel 0. Then we have parameters here, and I'll leave the standard parameters in. This is a 10 nanosiemens synapse with reversal potential of 0 millivolts, so it's excitatory. We have a time scale of 10 milliseconds and an activation threshold at minus 20 millivolts of the presynaptic cell, and the slope of activation of 25 millivolts. Then there are several advanced features in here which I'll leave alone for now. We can fix the postsynaptic potential, we can introduce a magnesium block, we can use short-term depression, and we can use plasticity. All things that we have not discussed in this basic protocol, but which are explained in detail in the manual to StdpC. If I hit close, that completes the configuration. And all that is left to do is then to start the dynamic clamp. So I hit start. And you see a lot of messages appearing here. No channels being displayed. Dynamic clamp is configured with one chemical synapse. And it is started and is running. And here we see a little warning, which is typical if we reach voltages that are close to the maximum voltage that can be acquired. We get these high and low channel limits warnings, and that's something that needs to be heeded to. If this appears in your experiment, you probably have to readjust the acquisition range on your channels. Once you're done with clamping, you just hit the stop button, and that completes the clamping and the writing of the data to files. After this, you can offline analysis of your data separately, and you can close StdpC by just choosing File, Exit. Before you do so, you might want to consider to save your protocol, which is save the settings we did in this video, so you can use it next time you use dynamic clamp, just using the load protocol function. The other items in here are for loading and unloading scripts. This is a functionality that allows you to change parameters during runtime at certain pre-specified times. And the other one is to export the log that you just saw in that message window, or to clear it. I'll choose clear here, so you see the effect, and then I'll exit the program. And this completes this demo.